Hey guys, this is your Madam Vash and welcome to my channel.
In this video, I'll be showing step-by-step working to solve a question on electron transition under Bohr's atomic model. The first question here requires you to determine the transition of electron which emits photon with wavelength 1280 nanometers in the Paschen series. First, write out the equation that is required to calculate wavelength. That would be 1 over lambda equals to Rydberg constant multiplied by 1 over n1 squared minus 1 over n2 squared, whereby n1 must be lesser than n2. Do recall that for Paschen series, the transition of electrons from higher energy level goes down to the ground state n equals to 3. Since n1 must be lesser than n2, therefore n1 value is 3. Now let's substitute in the corresponding values into the equation. That would be 1 over 1280 times 10 to the power of negative 9. Make sure to convert nanometers into meters, equivalent to the Rydberg constant with value 1.097 times 10 to the power of 7 multiplied by 1 over 3 squared minus 1 over n2 squared. Solving this would give you an n2 squared value of 25. Thus, the n2 value would be 5. In order to answer the question, do conclude by saying the electron transition is from n equals to 5 to n equals to 3. Now let's look into the second question. Here, you are required to calculate the energy change for the formation of the line with the lowest energy in the Paschen series. Do note that formation of the first line in a line spectrum has the lowest energy. Therefore, the first line in Paschen series would be the transition of n equals 4 to n equals 3. Next, in order to calculate energy change, the formula you require is delta E equals to RH multiplied by 1 over n initial squared minus 1 over n final squared. Substitute in the corresponding values. That would be 2.18 times 10 to the power of negative 18 for Rydberg constant multiplied by the initial n, that would be 4 minus the final n value, that would be 3. Solving this would give you an answer of negative 1.06 times 10 to the power of negative 19 joule. Conclude your answer by saying, therefore, the emission energy is 1.06 times 10 to the power of negative 19 joule.
Thank you for watching this tutorial. I'll see you in the next.